Hello, this is Past Paper Guy. Welcome to this video. I'm going to be solving the AQA specimen paper for A-level physics. It was set in 2014 and it's for the new specification. This one is the paper 1. As with all of my videos, this is to try and help you improve your A-level physics. So the way I would suggest you approach this is by finding the paper, downloading it, giving it a go, and then watching this video once you've given it a go. I'm going to be talking through the solutions and saying why the answers are what they are, rather than some videos which will just show you what the answers are and the mark scheme which will just tell you what the answers are. So I'm going to be trying to explain it as I go along. The common type of smoke detector contains a very small amount of americium-241, so 24195 americium. Determine the number and type of each of the nucleons in one americium-241 nucleus. So nucleons are the protons and the neutrons inside the nucleus. So we have 95 protons because that's that number there. And then that's the mass number or the nucleon number. So we got that many neutrons and protons. Take away the number of protons, and that gives you 146. 146 neutrons. Americium-241 is produced in nuclear reactors through the decay of plutonium. State the decay process responsible for the production of americium-241. Explain your answer. Right, so we have to go from 94 protons to 95 protons. So 241 americium. So to do that, to balance this part here, we need to put a -1 down here. So that's a beta particle. And if we're going to be correct about it, we get an anti-electron neutrino as well. So that's beta minus decay. So that's the state bit. Explain your answer, because the proton number has increased by 1. Now I think in the mark scheme for this, if you actually write that down, you can certainly get 1, if not 2 of the marks, just by writing that equation there. An americium-241 nucleus decays into nuclide X by emitting an alpha particle. Write the equation of the decay and determine the proton number and nucleon number of X. So we have 24195 americium goes to something something X plus an alpha particle. So you must know off by heart that an alpha particle is 42, like that. Then you just have to make the numbers add up. So that's got to be 237 plus 4 gives you that, and that has to be 93, so nucleon number 237, proton number 93. The alpha radiation produced by this causes ionization of nitrogen and oxygen molecules in the smoke detector. State what is meant by ionization. Ionization is when an atom loses or gains. It will be loses in this case, but it just says what ionization is, not what it is in this case. So ionization is when an atom loses or gains electrons, and what happens then therefore becoming a charged ion. So that's what ionization is. You need to know that, it's a definition. So ionization is when you gain or lose electrons. Okay, a friend who has not studied physics suggests that a smoke detector containing radioactive material should not be sold. Use your knowledge of physics to explain why the americium-241 does not provide any risk to the user. Okay, the first point is to say that because alpha particles are highly ionizing, it means that their penetration is very low, so they won't escape the case of the smoke detector. So because alpha particles are highly ionizing, they have low penetration, so none will escape the case of the detector. Okay, it's a 2-mark question. We've only said one thing, so we need to think of something else. The clue that they want you to use is up here. It's a very small amount of americium, and the amount of americium is small, so poses no risk. So that means that the amount of radiation coming off it is not that much higher than background radiation.